All right, number 11, we're going to be graphing here. So we've got exponential problem. I'm going to type this in the calculator so we can get our points from our table. So, okay, so we got it open to y equals, so a negative 7, raise it to the power of x, then we're done with the exponent, so arrow to the right, minus 1. We go to table, so second table. And I'm going to see, yeah, so there's a whole bunch of negative ones. That's just, that's rounded, it's not exactly, so don't think that those are real. Really negative 1. But here are some nice ones to use, like 0, negative 2 is a good one. 1, negative 8. I don't want to get this big, so I'll probably go back and use the negative 1 and then a decimal for one of my points. So negative 1, comma, negative 1.143. And then 0, negative 2. And 1, negative 8. So on all of these, your domain is all real numbers. You can have positive, negatives, etc. Your range, though, is limited to the negative 1. We can start plotting these points. That'll help us understand that. But negative 1 in just a bit. 0, negative 2. And then 1, negative 8. 1, 2, 3, 4, 5. Then I go off the graph. About 6, 7, 8. So it's about there. And we have this horizontal asymptote at y equals whatever our k value is, which is negative 1. So at negative 1, there's this asymptote that we're getting closer and closer to. And so I want to hit my point, but then curve and make sure I just follow the asymptote, don't cross it. So our range then, everything was below it, and it was below it because there was that negative a value. So we would say y is less than, and then whatever that asymptote is, whatever the k value is, which is negative 1. Number 12, and type that one into the calculator. So we have 1/5 to the power of x. I'll go to my table here. Let's grab some nice numbers. Negative 1, 5 is something I can handle graphing. 0, 1. And then I'll also use this 1, 0.2. 0.2 is also called 1/5. So those are nice ones to graph. In the k value, notice there's no number added at the end, so it's really a 0. So my horizontal asymptote is the point y equals 0. So we've got to hit our points, curve, and then follow that asymptote out. Our domain can be anything, so all real numbers. Our range, it's above that, so y is greater than that k value, which is 0. Number 13, we're trying to solve 9 and 27. They're both powers of 3. 9 is 3 squared. 27 is 3 to the third. And both of those powers already had exponents, so I'm going to have to multiply it or distribute here. So the first one I have a base number of 3 and then distribute the 2, so I get 6c plus 2. And then in that second one, distribute the 3, giving me an exponent of 9c minus 3. And now I can set my exponents equal to each other. 6c plus 2 is equal to 9c minus 3. Subtract the 6c. I'm going to have to go over here, so 2 is equal to 3c minus 3. Add the 3 over. 5 is equal to 3c. And so divide by 3, because I want the c by itself. So c is 5/3. Number 14, those are both powers of 2. 8 is 2 to the third. 16 is 2 to the 4th. Multiply those exponents, distribute. 6y plus 12. 4y plus 4. So 6y plus 12 is equal to 4y plus 4. As long as the base numbers are the same, I can say that. So I'm going to subtract 4y. So then I'll also subtract 12. So 2y is equal to negative 8. So y would have to be negative 4. Number 15. We're talking about interest compounded twice per year. So we're doing a compound interest equation. We have our principal times 1 plus our rate divided by n. N is how many times we get interest in the year, to the exponent of n times t. So there's our equation. We initially invested $21,000. That's our principal. 1 plus 13.2%, but we have to change it to a decimal. You move the decimal 2 places to the left, so 0.132 divided by how many times we get interest a year. We're getting it twice per year, so that's 2 times a year. So n shows up in my exponent also, times the number of years. We're talking about 12 years. And so we'll type this into the calculator. So we have 21,000. 1 plus 0.132 divided by 2. Close the parentheses, and for an exponent I have 2 times 12, which is also 24. So we get $97,362.61. Number 16. Just simply rewrite the form. This is in logarithmic form, so we write it exponentially. So 6 to the 3rd equals 216, and finished. Next one, 2 to the 6th equals 64, and finished. Now we have exponential, so we have to write it as a log. So a log base in 5 becomes the base number. Jump across the equation. 125 is equal to the 3. Finished. Number 19, write it in logarithmic form. Log base 7 of 1 that is equal to 0. All we did is rewrite. There's no solving to do there. Now in number 2021, they want us to evaluate. So they're saying here, number 20, 3 to some power is 81. Well, 81 is 3 to the 4th. So 4 is our answer. 3 to the 4th is 81. Here, 7 to some exponent is 1 over 49. Well, to get from 7 to 49, your exponent had to be 2. 7 squared is 49. But because it's in the denominator, the exponent had to be negative. So our answer is negative 2. 7 to the negative 2 is equal to 1/49. Number 22, we're going to graph. I didn't get this change. I don't really care so much about the x-intercept. I care about the domain and range. As well as our vertical asymptote. That will be helpful to know. So we have an h value of -1, so our vertical asymptote is x equals -1. Our domain x has to be greater than that. And our range then is all real numbers. Plug it in the calculator to get some points. So we go into y equals. I'm going to go to math to log base 3 of x plus 1. Go to table. I've got 0, 0. And I got 2, 1 as nice points. Vertical asymptote's at -1. So make sure you don't touch that. Just follow out that asymptote. All right, and there we have it.